Hey everyone! Today we're diving into hypothesis testing, a fundamental concept in statistics and data science. Basically, it helps us figure out whether the results we're seeing in our experiments are actually meaningful, or just random luck. This is super important for things like A/B testing your website, comparing machine learning models, or really any time you need to make data-driven decisions with confidence. Let's walk through the hypothesis testing flow. First, you define your null and alternative hypotheses about what you expect to see. Then you collect your data from the experiment. Next, you calculate a test statistic that measures how far your result is from what the null hypothesis predicts. You convert that into a p-value, which tells you the probability of seeing your result by chance. Finally, you compare the p-value to your significance level, usually 0.05, and decide whether to reject the null hypothesis or not. The heart of hypothesis testing is these two competing hypotheses. The null hypothesis, or H0, is your skeptical position that assumes nothing has changed or there's no real effect. Think of it as innocent until proven guilty. The alternative hypothesis, H1, is what you're actually trying to prove, that there is a real effect. The p-value is your key decision metric. If it's low enough, typically below 0.05, you have strong evidence to reject the null hypothesis and accept that something real is happening. Let me show you a classic example. Say you're running an A/B test on your website button. The old button gets a 5% click rate, and your new design gets 6%. Is that 1% difference real, or just luck? You set up your hypotheses. H0 says there's no real difference, H1 says the new button is actually better. After running a statistical test, you get a p-value of 0.03. Since 0.03 is less than our threshold of 0.05, we reject the null hypothesis and conclude the new button really does perform better. Time to ship that change. So to sum it all up, hypothesis testing is your scientific method for validating whether results are real or just random chance. Remember that the null hypothesis is what you're trying to disprove, and a low p-value gives you the confidence to do that. This technique is used everywhere in tech and science, from optimizing websites to validating new drug treatments. One important note though, statistical significance doesn't always mean practical importance. A tiny effect can be statistically significant with enough data but not worth implementing. Now you've got the foundation to start testing your own hypotheses.